Hi everyone, I'm going to show you how to use our seasons in 3D Gizmo. So this is how it looks like when it starts, and I've got my Google Doc right here. So it says the first thing we've got to do is set the latitude in the description. So this is the description tab. We're going to set the latitude to 45 degrees, and we can type in there 45 degrees. Then we're going to drag the slider at the bottom to June 21st. So here to June 21st. Then it says, is the northern hemisphere tilted away toward or away from the sun? Well, it's clearly tilted towards, so you type that here. How much light, that's B here, is falling on the northern hemisphere compared to the southern hemisphere? Well, it kind of looks like there's a lot more light on the northern hemisphere here. And then change the date to December 21st. On this date, which hemisphere is receiving more sunlight? So I'm going to use this little bar here again. December 21st. Well, now it looks like the southern hemisphere is. Now we're going to move the simulation speed slider all the way to the left. Well, it's already here all the way to the left. Select the 2D view tab and make sure facing south is selected. So here's 2D view. South facing south is selected. Set the date to June 21st. So we're going to go back here to June 21st. Oops, that's July. There we go. Click play. Click pause when the sun reaches its highest point in the sky. Draw and label that picture, position on the picture right here. And then you're going to do the same thing for December 21st. So if you're on an iPad, you probably want to put this file into Notability because you cannot draw with Google Drawings on the iPad. It's kind of a pain, but it's the truth. All right, I'm going to click play. I'm getting ready to pause. And the sun looks about highest right here. So I draw it up here. I will let you do the same thing for December 21st. Then you're going to say which date was the sun higher, and that's the summer solstice. And then the lowest is the winter solstice. And then you're explaining how does the orientation of the Earth's axis, so how does the fact that the Earth is tilted like this relate to the position of the sun in the sky? How does this tilt cause the sun to be where it is in the sky for us? And then you're going to do kind of the same process with a negative 45 degree latitude. So you're going to go back to the description and change this to negative 45 degrees. You're going to predict, is the sun going to be highest at negative 45 degrees on June 21st or December 21st? Then you're going to go back to this 2D tab and do the same thing you did before with June 21st and December 21st. Answer those questions about the northern versus the southern hemisphere. And then in section B, we're going to reset the gizmo. You're going to make sure our simulation speed's all the way to the left. And the question is, why is it warmer in summer than in winter? I looked up the latitude for St. Paul. It is around 45 degrees. It's actually 44.95, but that's so close to 45. I'm not sure if we could put that in. You try it, 45, 44.95. Okay, I can. So maybe, oh no, it just rounds it up to 45. So 45 degrees. You know the typical summer day temperature and summer winter day temperature. Now we're going to go to this graph tab, which shows our solar intensity, or how strong the sun is. You're going to change the date to March 21st, which is the spring equinox. Click play. Then you're going to pause it before 24 hours have passed. You're going to answer these questions. Then you're going to do some data here for the 21st. And then June 1st, September 23rd, and December 21st. And then you're going to compare which is the longest day of the year, which is shortest. What does equinox mean based on this? Why is the noon solar intensity greater on their summer solstice than the winter solstice? Then you're going to reset the graph and change your simulation speed to the highest value, so all the way over. Then you're going to switch to the year graph and click play, and then after you've seen a year happen, you're going to draw the results. And then what factors are responsible for the changes you see. You're going to summarize stuff. And then you're going to do the same thing except with negative 45 degrees here. So that's the whole gizmo. Hopefully that answers, hopefully it answers your questions. And have a wonderful day.